And welcome back. Okay, so this video, we're going to do a slope of the tangent line thing. Okay, so cosine. This is an implicit problem, but it's also a slope of the equation of the tangent line problem. Cosine of x minus y plus sine y equals the square root of 2. Okay, so we have this implicit thing going on, and we want the slope of the tangent line at the following point. And they give you this. This is given information. Pi over 2, comma, pi over 4. All right. So, first, equation of tangent line. All right. So we have the good old point slope form. This is something that you should have memorized and ready to use at any time. Okay. Basically, if you know one point, which we have here, basically this is x1, this is y1. All we need is the slope, and let's remember, right? The slope is the derivative evaluated at the point. In this case, it's the derivative evaluated at pi over 2, comma, pi over 4. All right. So before we can do this, we need to find the derivative of this expression, dy dx. Okay. So we apply the derivative operator to both sides, just like all the other problems like this. Cosine of x minus y plus sine y, derivative, equals, and then d by dx of the square root of 2. So all I did was apply the derivative operator to both sides with respect to x. All right. So here we go, right? So term number one, the outermost function is cosine. Derivative of cosine is negative sine. Keep the inside the same. And now we multiply, now we go inside and take the derivative of everything here with respect to x. So here we go. dx is going to be 1 minus, and then this is going to be dy dx. Okay, awesome. Next, plus derivative of sine is cosine. Keep the inside the same. This is chain rule. And then once you handle the outside, then go inside. So inside is y. We want dy dx, right? If it were an x, it would be dx, which would be 1, which isn't what we have. And then on the right-hand side, square root of 2 is a constant. Derivative of a constant, nothing. All right. So, just like before, just like all the other implicit problems that we've looked at, we want all the dy dx terms on one side and all the terms not involving dy dx on the other. So that means we have to distribute this sign. Okay, so negative sine of x minus y times 1 is, well, negative sine of x minus y. Negative sine, so we have this negative sign multiplied by the negative dy dx. Negative times a negative will be a plus. And then it's going to be, I'll write dy dx first. And then sine of x minus y. And then I'll go ahead and write this guy back down. Cosine y, dy dx equals 0. Awesome. So now we have 1, 2, 3 terms, 2 of which have dy dx. So what I'm going to do is I'm going to send this term to the other side because it does not have a dy dx. All right. Very cool. Very cool. So let's write down what we have. Dy dx sine of x minus y plus cosine y dy dx. It doesn't matter what order you write this in, it's multiplication. And then equals sine of x minus y. Now on the left hand side we can factor by greatest common factor dy dx, leaving the sine of x minus y plus cosine of y. And then the right hand side is unchanged. Alright, now that we have dy dx factored, we can divide both sides by the thing multiplying dy dx. In other words, we can multiply both sides, or I'm sorry, divide both sides by the sine of x minus y plus cosine of y. Divide here as well. Divide by sine of x minus y plus cosine of y. There we go. Okay. And then these two things are identical. So, you divide something by itself, you're going to get 1. So it cancels out. You might be tempted to cancel these, but don't. Right? If you want to cancel a sine of x minus y, it has to be present in every term. This term does not have a sign, so don't even try it. Okay? So we get dy dx equals the sine of x minus y over the sine of x minus y plus the cosine of y. And now, do we have everything we need to find the slope? Yes, we do, because dy dx is the slope. Okay. The x value is pi over 2. The y value is pi over 4. So wherever I see a y, I'm going to plug in pi over 4. Wherever I see an x, I'm going to plug in pi over 2. And I get the sine of pi over 2 minus pi over 4. I'm just plugging in x equals pi over 2, y equals pi over 4. Same thing here. And then plus the cosine of pi over 4. All right. Good. So sine of pi over 2 is pi over 2 minus pi over 4. Oops. Let's fix that, yeah? Pi over 2 minus pi over 4 is certainly pi over 4. Okay. Same thing down here. Sine pi over 4 plus cosine pi over 4. Okay? Pi over 4, right? Let's remember, if we've forgotten, right? Pi is 180 degrees. Divide by 4, divide by 4. Pi over 4 is 45 degrees, right? And that gives us a little boom, 45, 45, 90, right? 1 square root of 2, right? X component, Y component, R component, yeah? So the sine of pi over 4 is going to be 1 over square root of 2. And so is the cosine. They're going to be equal. So what we wind up with is 1 over square root of 2 over 1 over square root of 2 plus 1 over square root of 2. Look at that. Which winds up being 1 over square root of 2 over, and then 1 plus 1 is 2, right? 2 over square root of 2. And can we simplify further? Of course we can. 1 over square root of 2 over. And then 2 over square root of 2. 2 over square root of 2 is literally just the square root of 2. Let me write this in a more suggestive way. 1 over square root of 2 and then times. This is square root of 2 over 1. So we can play the keep, change, flip game, yeah? 1 over square root of 2 times 1 over square root of 2, which is 1 over square root of 4. Square root of 4 is 2, so this is a 1 over regular 2. All right, and then that's our slope. 1 over regular 2, 1/2. Okay. It looks like I'm all the way down at the bottom here, so I guess I will go up a little bit. So we have everything we need because we know what y1 is. We have the slope, we just calculated it, and we have x1. So we get the following line, y minus pi over 4 equals m 1/2 x minus, and then pi over 2. So there's my point slope form. You may also see it this way, y minus pi over 4 equals, distribute the 1/2 x minus pi over 4. And then I can add pi over 4 to both sides. And if I do that, it goes away here. But pretty cool, it also goes away here, yeah? And when we wind up with the following, y equals 1/2 x, which you can also write as x over 2. All right. So yeah, pretty cool. So there we go. Slope of the tangent line problem with trig with implicit derivatives. Whew. Yeah. Good. So I'm going to call it. And yeah, I should have started up there. Anyway. See you next time.